Hey guys, so today we are going to talk about dilations, and this is probably one of my favorite units. So, if you haven't guessed yet, a dilation is either going to make something, the figure is going to either enlarge or it's going to reduce with respect to a fixed point. So, if you look at my little um, GIF, whatever it's called, his eyes are getting larger and smaller. So his eyes are dilating. Okay. So the way we represent that is XY yields. This sign means yields. You will see that also in science when you're talking about products and reactants. KX, KY, where K is going to be your scale factor. And we have talked about that in a previous lesson. So basically, dilations, the easiest way I can describe this for you is every time you see the word dilations or dilated, think of the word multiplying. Okay. So you are basically just going to be multiplying by whatever scale factor they give you. Okay, so let's look at example 1. It says, draw the image after having a dilation, keyword, multiplying, having a scale factor of 2. So I'm going to take A and dilate that. And A, to represent the new, you're going to put A prime. And I'm actually going to adjust because we are not going to fit if I keep the size the same. Okay, so all I'm doing is multiplying my numbers by 2. So 2 times 2 is 4. 2 times 3 is 6. So my new A prime is 4, 6, or my new A is 4, 6. Now, from B to get to my B prime, I'm going to do the same thing. I'm going to multiply by that scale factor, which is 2. So 3 times 2 is 6. And 1 times 2 is 2. So that is my new point for B prime. Okay, so C is 1, 2. To get to my C prime, I am going to multiply again. So 1 times 2 is 2, and 2 times 2 is 4. So my new coordinate is 2, 4. Okay. So pretty easy. All you're doing is multiplying your scale factor by the coordinates, okay? Now, if they don't give you the coordinates, you're going to have to find the original coordinates first and then multiply by that scale factor, okay? So let's look what happens. One thing I wanted to point out. If I'm going from 2, 3 to 4, 6, 3, 1 to 6, 2, 1, 2 to 2, 4, I'm noticing, or I should be noticing, that my numbers got bigger. So because my numbers got bigger, that means that my figure got bigger or it enlarged, okay? Now let's see what happens when I have a scale factor less than 1. Okay, so my scale factor is 0.5 and I'm still dilating, so that means I'm still going to be multiplying. So now I'm going to multiply negative 6 times 0.5 to get m prime. And I'm actually going to change the font. I will have this changed for you guys, so no need to worry. Change the font to m prime becomes half of negative 6 is going to be negative 3. And half of negative 4 is negative 2. And I'm just going to adjust it so you can see it all in one. Let me enlarge the rest because I know that's going to be an issue. Sorry. Okay. So with A prime, I am going to do the same thing. I'm going to dilate, or I'm going to multiply by half. Half of negative 2 is negative 1. Or negative 4 times 0.5 is going to be negative 2. T prime T prime, again, we're going to be multiplying that scale factor, that 0.5, and I get 0.5 times -2 is going to be -1, and 0.5 times -6 is going to be -3. And then finally, my H prime, that is going to be -6 times 0.5, that is going to be my -3, and -6 times 0.5 is also -3. So my new coordinate for H prime is -3, -3. So if I'm looking at my originals and then I'm looking at my new, I should have noticed that my numbers got smaller. So this would be an example of a reduction, okay? If my numbers are going from big to little, that means I got smaller. It's a reduction, okay? So in dilations, the pre-image and the image, so this would be the pre-image, the original, and the image is your new. They are going to be similar, okay? Because it's the same shape. We're still dealing with the same shape. They're just different sizes. Sorry, I'm going to repeat that. They are similar because they have the same shape, but they're different sizes. They're either going to be an enlargement or they're going to be a reduction. Okay. Your corresponding angles, however, are going to be congruent. It doesn't matter how big or how small your dilation gets. If it is a true dilation, your corresponding angles are always going to be the same. They are always going to be congruent. Okay. And if it is a true dilation, that means that your sides are going to be proportional, meaning I can put it in a proportion and they will be equal to each other. Okay. Or you can find your scale factor, which is what we were talking about in the previous notes that we had. Okay. So here is your practice 1 and your practice 2. Please, here are your original points. You don't have to graph, okay? Remember that when we're talking about dilation, all that means to do is that you're going to be multiplying, okay? You're going to be multiplying to get your new coordinates. Please also bear in mind when you're giving me your new coordinates so that you don't have to say, oh, this is the new A, put that little prime notation, okay? When you put that prime notation, that lets me and anybody else know, hey, this is the new one. Because it has this apostrophe, it is the prime notation or the new one. Okay. Also, I would like you to tell me if your figure is going to enlarge or get bigger, or is it going to reduce? Is it a reduction? Is it going to get smaller? Okay. I hope you guys enjoyed this lesson. And if you have any questions, please let me know. I am here to help.